In the previous episode of Rust, we have seen an example where we tried to pass a string to a function called return length, and we were trying to just return the length of the string. We were not returning string before, but we tried to return the length of the string. But after that, when we tried to print the original string, which is str1, we got an error that it is no more there. That's why what we had to do was we had to return the string as well from the function and then pass it to the str1, original str1, and then print it. So basically when we pass the str1 to the return length function, the ownership was shifted to this s. The any string ownership was shifted from str1 to this s. And when the function is over, this s, the scope of s was over. So the value was dropped. That's why str1 doesn't have anything. So to avoid that, what we have done is like we returned the string as well, and we passed it to the str1 again. So the ownership is passed to str1 again. How can we avoid passing ownerships like this? It's very cumbersome to pass ownerships again and again to get the required result. It's very cumbersome to do that. So for that, what we can do is we can use something called references. And this episode of Rush series is all about references and how many types are there of references and how we can use them, what are the rules of using it. We'll see all of them. So let's get started. But before getting started, don't forget to like, share and subscribe to this channel, and share the channel as much as possible because it encourages me to do more videos and more regularly as well. Let's see what problem references is solving for us. So when we try to create any string, this is the any string, and as we have said before, anything that size we don't know before creating, it is stored inside heap. So let's say this is stored at some address, something called abcd. So this is the address of this any string. This is inside heap. Now inside stack, if we have assigned it to str1, right? So this will be inside stack, and this will have the reference abcd, so that it keeps pointing to this particular string. That's how we get value whenever we use str1. As we have said before, when we try to assign it to s, as like this, or when we pass it to other function and s is part of the parameters of that function, this is what's happening. It is trying to point to this particular string, and this pointer is no more valid. This str1 is no more valid, and it is now pointing to s. This is what happening. This is what the transfer of ownership is. But if there is a way that if we can maintain references for both of these, even if we pass it to some other variable like s or some other function like what we have done before, like return length function, and we were using s as a parameter there, if we can have references to both of these, it will be easier. I mean, we don't need to return this back to the previous thing from the function. We don't need to do all of those things, passing the ownership. Here we are not trying to pass the ownership, we are trying to pass the reference. So basically we want to pass the reference. Okay, this is how I am referring to this any string. You just reference in the same way. I am not going to give you the ownership. I am just going to tell you how I am referencing it. You just reference in the same way. If we can do this, it will be easier for us to pass values to anything like functions, or just give the value to some other variable in the program. Now let's see how we can pass references instead of ownerships. So let's get out of this project and let's create a new one, which is cargo new references. I created this project references, and I'm going inside main.rs file. Now I'm just copying this entire code. And pasting it here. This is the previous example as well. So what I'm trying to do is I'm just trying to remove this everything, and I'm trying to generate the error that we got for the first time when we tried to pass the ownership for the first time. When we try to print the str1 without getting it back from the return line function, we got an error that str1 is no more there. Now let's return only the length and not the string, and save this. I have to change the types as well. Okay, now if we try to go into the references project and now try to cargo run. It's saying value borrowed hereafter. So it's basically saying str1 is not there anymore. That is the reason why we returned it from this function and took it to the str1 again, and then we printed it. That's how we solved the problem of ownership. Now if we, as we said in the previous demonstration, if we can pass the reference, both of these str1 and s have the reference to it, and we don't need to return it back from this function. So how we can pass the reference? For that, first we have to say this s that it is going to get the reference of something, and it is not directly getting the string, it will just get the reference. So for that, what we have to do is we have to specify this ampersand symbol. This will specify that it is going to get the reference of some string and not the string as it is. Now we have specified that it is going to get the reference to the string. Now what we have to do is, while passing it, what we have to do is we have to pass the reference. How we can do that? Using the same ampersand symbol. Now what it is doing is, this particular parameter is expecting a reference to a string, and while we are passing it, we are also passing the reference to that string. We are not passing the str1, now we are passing the reference to str1. How we can do that? Using this ampersand symbol. Now if we save it and if we run it, there shouldn't be any problem because we are just passing the reference. While passing the reference, the ownership is not transferred, so str1 is still valid. When we try to print it, it should print the any string as it is. So now you can see it printed any string without any error. That is because we haven't passed the ownership of the string, we just passed the reference to that string. Now before returning the length of the string, let's try to change the string a little bit. We are getting the reference of the string str1 and we are calling it as s inside this function. Let's try to change this s. How we can do that? We can append the string using this function called s dot push str. So it will append the given string with whatever we specify here. Let's append the given function any string with some here. I'm giving a space here so that it will give space at the end of this any string. So I'm putting a semicolon, and before trying to compile it, let's change this to mute, because we are trying to change the value inside this str1, so it is good to give mute here. Now if we try to run this, it's saying some error, which is s is a reference, so the data it refers it cannot be borrowed as mutable. We are trying to change the value inside this reference, but we haven't specified that we are going to change it. So as we said before, there are two types of references, one is immutable and other one is mutable. By default, any reference is immutable, so that we can only read the value inside it and we can't change the value inside it like how we are doing it here. How we can make it mutable? We want to change the value inside the function. So for that, we have to pass it as mutable reference. How we can do that? First of all, we have to specify that it is going to be a mutable reference and not just normal reference. How we can do that is specifying mute keyword. Now instead of just ampersand, we have to give ampersand mute and the type of the reference. And here while passing as well, we have to give ampersand mute instead of just ampersand. If we save this and if we try to run this, now this won't produce any error and it's successfully appending the string, and we are able to print that string as well by passing the reference back. Oh sorry, we are not passing the reference because we don't need to pass the reference because we are not shifting any ownership of it. The str1 will automatically get updated because both of them are referring to the same value, same memory in the heap. We have certain rules that we need to take care of while using references, because these rules are there to avoid any issues related to memory leaks, everything. So for that, we have to follow some of the rules, and if we don't follow, we will get a lot of errors and we are not able to even debug them, because these particular rules are not there in any other programming language that I know of. So this is something new even when I try to see for the first time. So we need to be careful while trying to use references in a Rust program. Let's see in practical what are these rules and why we need to take them seriously. For that, what we want to do is, let's remove all of this, and we don't need this function either. Let's remove everything. So what, let's do one thing. Let's try to create a string str equal to string from something. This is a string. Is str a valid name? No, it's not. So now we have a string str1. Now let's try to create some other variable str2. Let's try to assign the reference of str1 to this str1. Now str2 is also referring to the same string something. This, remember, this is just a immutable reference. We can't change any value using this str2. Let's try to create another string str3, and it also refers to the same string, which is str1. Now we have three strings, all are pointing to the same string, but only str1, even str1 is not mutable because we haven't specified mute keyword, but it has potential to do that. But str2 and str3 are just immutable references to the str1. Now let's try to print all these things. Using placeholders, we have given three placeholders, and let's give str1, str2 and str3. Fine. Now let's try to run this. Sorry, I have to give underscore str1. Save this and run this. We got something, which is expected because all of them are pointing to the same string something. Now let's try to make this str1 mutable, and let's try to make this assignment as mutable reference, not just normal reference. The str2 is having a reference to the str1, but it is immutable reference, and str3 is having the reference to the str1, which is mutable reference. This is valid because str1 is mutable, so we can have a mutable reference to str1. This should be valid. Let's try to run this. It's saying error. That is because in a scope there should be only one mutable reference and no any other references to a particular value in the memory. So what I meant is, like, this is a scope, and in this scope there is one mutable reference to str1, and there should be no other references, either mutable or immutable, to the same particular reference, same particular value. If we try to move this line here and remove str3 because str3 is not there yet. Now we have created str3, and now let's print str3 here. Save it, remove this placeholder as well, save it again, and try to run this. This won't generate any error. Why is this happening? So while trying to create references, we have to keep in mind a particular rule, which is, if it is an immutable reference, we can have any number of references in a scope. But when it comes to mutable reference, we can have only one mutable reference and no other reference, irrespective of the type. If there is one mutable reference in a scope, there can't be any other reference, either mutable or immutable, in that particular scope. That is the reason why we got that error earlier. When we try to do this earlier, in this particular scope, we are having two references to str1, and one of them is mutable reference. So this is the reason why, what we have discussed before, when we have a mutable reference, there shouldn't be any other reference in that particular scope. str2 is not dropped because it is using still here in this println line. Why do we need to follow these rules? We need to follow these rules to avoid something called data race condition. Let's just go through an overview of what race condition is in general. So when there is a resource, this can be any resource, and there are multiple contexts. Let's say we have a context 1 and context 2, and both of these are trying to use the same resource at the same time. This is a race condition. Both of these are in a race to use a particular resource. for example, there are two apps running in your PC, and there is this, let's consider the keyboard is a resource now, and both of them are trying to use the keyboard at the same time. What operating system does is, it has something called synchronization mechanism using locks, and it will only allow only one of them to use the keyboard at one point of time using a lock. Let's say there is something called a variable called lock, and it can take either 0 or 1. 0 means in use, 1 means not in use. So when context 1 is trying to use this keyboard, it will keep 0 in this variable and then keep using it, so that when context 2 is trying, it will see 0, so it thinks that keyboard is already in use, it will pause it. So when context 1 is done using the keyboard, it will turn this into 1, so that other context can see that it is 1 and it can use the keyboard now. If both of them are trying to use the keyboard at the same time without the lock system, the keyboard gets blocked and none of them can use it. So this is how basically the lock system is used to allow synchronization when it comes to resource. So when we talk about data race condition, the resource here becomes the memory. So this is memory resource, and in our example we are having any string as our str1. str1 is pointing to any string. When we are having str2 and str3, both of them pointing to the same thing, when we try to use both of them at the same time, we get something like what we have seen before. So for that we need to have some synchronization mechanism. When both of these are immutable, there is no problem, because both of them are just trying to read the value. So the basic operating system will let you have the synchronization mechanism to read both of them simultaneously. But when it comes to when one of them is immutable, let's say one of them is immutable and this is immutable, here the problem arises. The Rust has no synchronization mechanism to allow this. So when str3 is trying to update the value inside this str1 and str2 is trying to read the value at the same time, the problem arises. So there is no synchronization mechanism in Rust to allow this. So that is the reason why it doesn't allow more than one reference if that reference is mutable. I hope you have understand what I tried to explain in this video, and if you like this video, please try to share this video as much as possible in your social media and subscribe to the channel for the future episodes of Rust series. And that's it for this video, and see you in the next episode. Until then, bye bye.